Alright guys, in this video we are going to talk about section 2.5 with complex zeros and talk about the fundamental theorem of algebra, which is a pretty large idea we've got to cover. Basically, your fundamental theorem of algebra is what you see on your screen right now. It says that a polynomial function of degree n has n complex zeros, and complex means real and not real, okay? And some may repeat. So you can always look at the degree of your function, and it tells you how many zeros it has. Those zeros can be real or not real. They might repeat, they may not. It just kind of depends, but you can always tell the number of zeros based off of the degree. Some of them may actually hit the x-axis, some of them may not, okay, because they may not be real. So if you're seeing in example 1, it says to write in standard form, identify the zeros and the x-intercepts of that graph. So zeros and x-intercepts a lot of times are the same thing as long as they're real, but if they're not real, then it doesn't actually hit the x-axis at those zeros. So we'll talk about the difference between those in just a moment, okay? So let's look here at part A. We've got this problem where you see some i's. Now this is going to have to make us remember from Algebra 2 how to deal with imaginary numbers, but we'll deal with that in just a moment, okay? We're going to FOIL it out. So x times x gives you x squared. X times 2i gives me plus 2ix. Then we have negative 2i times x, negative 2ix. And then we have a negative 2i times a positive 2i. That's going to give us a negative 4i squared. All right, so here we go. We got x squared. We have 2ix minus 2ix. Those guys cancel each other out. They're gone. And then over here we have this minus 4, and we need to talk about what is I squared. Well, I squared is the value negative 1. If you recall from Algebra 2, when you talk about I is the same thing as the square root of negative 1. So if you square that, you just get negative 1. Okay? So we have really a negative 4 times a negative 1 because that's times the I squared. And so that really cleans up to be x squared plus 4. Huh? Now, they had said to identify the zeros and the x-intercepts. Well, my zeros are going to be these numbers that we had back here, the plus and minus 2i. So let's say zeros. Let's say plus or minus 2i. Okay? But my x-intercepts, because these are not real, they don't actually hit the x-axis. This graph wouldn't. So we're going to say no real. Okay? If there are real ones, then we would list those. But both of them were imaginary. All right, let's look at the next one. This one's a little bit more going on. We have a similar situation with our imaginary numbers over here. Those are more complex. And then we do have a real one right over here. So I'm going to have that x minus 5, and let's deal with this complex situation going on over here. So I'm going to multiply out x times x to give us x squared. X times the square root of 2i is plus the square root of 2ix. Then we'll have negative square root 2i times x, right? Inside times inside. Negative square root of 2ix. And then last times last, we get negative times a positive is a negative. Square root of 2 times square root of 2 is just 2. I times I squared. And we can clean this up a little before we multiply some more. We've got x squared. Now look here in the middle. We have that positive square root of 2ix minus square root of 2ix. Those cancel and are gone. Over here we have minus 2 times I squared, which was negative 1. And we end up with this situation. Okay? We still do need to multiply this out. So we're going to do that. We're going to FOIL the rest of it, and then we will be done. So multiply first times first. X cubed. Then we have outside times outside, which is plus 2x. Negative 5 times x squared, negative 5x squared. And then negative 5 times 2 is a negative 10. I'm going to rearrange this into standard form. And then we've got it. They said write in standard form. We did it. Now they said to identify the zeros. We'll go back to my original thing. That really shows me where my zeros are. Okay, my zeros were at the opposite of this guy, so 5. Then we also had the plus and minus square root of 2i. Okay, last little thing, let's talk about those x-intercepts. X-intercepts are where your zeros are real. Well, there was one real 0, which means I have an x-intercept at 5, 0. Okay? All right, that was that part. So, cool. Now let's talk about the complex conjugate zeros theorem, okay? We said that we're going to let f of x be a polynomial function if a and b are real with b not 0, and a plus bi is a 0 of f, then the conjugate a minus bi is also a 0 of f. Basically, if you see that complex number with that imaginary number in there, then that's not the only imaginary solution. You'll also have the conjugate where the only difference, I want you to see, the only difference is the sign between the real and the imaginary. A plus bi, a minus bi. So if that's the case, if you know that there is an imaginary solution, then there's always going to be a second imaginary solution. You can't just have one, okay? So if you look at example 2, it says write a polynomial of least degree, so the smallest degree possible, but that it also reaches these qualifications. It has to have zeros at x equals 1 and x equals 1 minus I. So I do see one complex 0 listed there, but because we know that complex conjugate zeros theorem, then we know that this is not the only imaginary degree, or not the only imaginary 0, sorry. It also will have its conjugate. So when we set this up to try to figure out what the equation would be, we're going to multiply out all of the zeros in their factor forms. So the solution here, x equals 1, we're going to use x minus 1 as one of the factors. But then we also have to deal with these conjugate things with the complex. What I'm going to do is put a bracket here, and the only reason I'm going to use a bracket is because whenever you have parentheses inside of parentheses, it gets kind of ugly. So I'm going to use a bracket to keep it cleaner. That's all. And I'm going to say x minus the 0 we know right here. Okay. But then we also should have another one, because you can't just have one complex one. We also will have to have another imaginary solution. So we'll have x minus the conjugate of this. And again, the conjugate just changes the sign between. So instead of x minus I, 1 minus I, it's 1 plus I. So this is what we're going to work out. Now, there are people who have all kinds of different methods to multiplying these things out. And I don't think there's just one right way. I do like to, I kind of just change it up to how I'm feeling at the moment, which I know is not the best answer to tell you. But let me see which one's a little bit faster. Okay, the method that's a little bit quicker is going to be the one where I distribute this negative through the parentheses before I multiply. Well, no, it's about the same length. It doesn't really matter. You can either distribute the negative through first, or you can distribute it later. It just kind of depends on how you're feeling. is it works the same. You get the same result regardless. So you could either distribute it now or you can distribute it later. It might seem less confusing to go ahead and do it now. So if we do that now, I'm going to make this be x minus 1 plus I, right? If you distribute that through. And then over here, x minus 1 minus I. Okay, so distributing it now might feel a little bit less ugly. Now, here's another suggestion I'm going to have for you. Don't try to multiply these first two. Start with multiplying the ones that are both imaginary. Okay, don't try to do one of the real ones with the imaginary because it's going to get a whole lot ugly. We just want to do the imaginary times the imaginary. Okay, and then we'll come back and deal with the real one later. All right, so let's multiply this out. We're going to do x times x, which is x squared, x times the negative 1, negative x times negative I x. Then take the negative 1, multiply it through negative x. We have plus 1. Negative 1 times negative I is a positive I. And we're going to multiply through the I times x. This is a positive I x. I times the negative 1 is a negative I. And then I times the negative I squared. Okay, so multiplying all of that out, that's what we should have got. We still have this x minus 1 hanging out in the front, but let's clean up this second part. We have x squared. Now I see a minus x, so that's negative 2x. We have a negative ix, and then we have plus ix over here. Those guys cancel. We have a 1, so plus 1. We also have I minus I. Those are gone. And then minus I squared. Now remember that minus I squared, that's minus a negative 1. Almost to the next part. So here, 1 minus a negative 1, that changes to be plus, right? So this is x squared minus 2x plus 2. And now we are ready to do the last little bit of multiplying. The imaginary numbers are gone. X times x squared is x cubed. X times negative 2x, negative 2x squared. X times 2 plus 2x. Negative 1 times x squared, negative x squared. Negative 1 times a negative 2x, positive 2x. Negative 1 times positive 2, negative 2. Go through, combine your like terms. I know it's not the prettiest thing in the world, but we do have to deal with tedious algebra sometimes, guys. All right, there we go. We have our answer. Isn't that gorgeous? All right, so what I'm going to do is pause the video here because this is going to conclude part A of the 2.5 lesson for my on-level kiddos. Now, I have an extra problem that's pretty intense we're going to go through with the AP class. So if you are in AP, you need to make sure that you watch part B, okay? Now, part B, it's not the end of the whole thing. So those of y'all who are in on-level, I want you to skip to part C. I hope that makes some sense. So we're just doing a problem in AP at this point where it is pretty intense, and I want the on-level kiddos to be able to skip it. Okay? So that's the deal. Yeah. Okay. I will see you guys in the next one. Remember, on-level, go to part C. Advanced, go to part B. Okay? See y'all in the next video. Bye.